Alright lads, so 2019 short questions. Handiest thing probably is if you cut these straight out of your book. It is nearly handier because it's very hard when it's inside the book, so you can take them out, maybe staple them together and put them back into the book, or sellotape them back in. Right, question one anyway. Question one is usually a multiple choice question, lads. So what have we here? So a line that touches a circle at one point is a tangent. Okay. Any line that goes from one point in a circumference to another point in a circumference is called a chord. Like an apple tart, if any portion of a circle that goes from a point in the circumference to the centre and back to another point in the circumference is called a sector. And when a sector is a quarter of a circle, it's a quadrant. So, quadrant. Right. Okay, second question here is a perspective question. So perspective just means you're drawing what it would. So when we draw in TechGraph, we do it in usually in pictorial, which means that we don't allow for measurements to diminish as they go further away. This particular question allows for that. So your vertical lines will stay vertical, but any line that's travelling parallel to the ground is going to vanish on a vanishing point in distance. So all the lines going this way along that are going to vanish out there. All the lines going this way are going to vanish out there. So we'll start anyway by finishing off the vanishing points on it. So finish that off there. So I do all these in 2H, of course. This fella here. So you have a good guide down the bottom there. The top one here. So even though it's high up, it's still travelling parallel to the ground, so it's going to go to the vanishing point. That'll do us there. And we'll do these ones down here in 2H. So this one travels out here. Out to the vanishing point. And this one here on the inside. Out to the vanishing point. Alright, so they're all in 2H. Okay, so I want to get this line here so we can see, like, we don't know where this stops here, but we can see if you made like a rectangle out of the end of it there, coming straight down from with that vertical line. So I use my sliding set squares to make sure I'm on vertical. Just use that as like a CRT square. I use one of these lines. Slide that along there. Bring it down. If you want to stick on the sheet, lads. If you want to stick on the sheet and use the vertical line, that's fine. So that gives me this point here, and then that travels parallel to the ground going this way, so it's going back to vanishing point 1. So I'll join that from the back. Okay, and I can see there where that hits the bottom part. That's going to be the starting line. So any line is the shortest distance from one point to the other. So I have that point, I have that point. So I have my line. I'll draw that in the H. And finish that out. Right, so that gives us that side. Next thing, I can do this little line on the inside here. So I have in 2H, I'll just finish it off. So that will go back there, but then it will disappear underneath the little cove on top, so that's gone. Okay, right, this white rectangle up here, it finishes at that corner there. So as I said before, vertical lines remain vertical. So I'll make sure it's vertical by lining it up with one of these lines, slide it over, and from that corner it goes straight up to meet that line going out. And then I join up what I need. Like that. Okay, so this gives me a new point out here. That's a line going this direction. It's parallel to the ground. So I'll join to vanishing point 2. There it is there. Alright, so now I've that line going back. That's where it ends in there. So I can draw the rest of this rectangle up here in perspective. Alright, that's there like that. So I have this side of it. The top or the lid of this piano. Is it a piano? What is a piano? The lid of this piano goes all the way out there And you can see there's a vertical line going straight up to cut off this line going back to vanishing point 1. So, square. Like that. I'll draw that vertical line. So it is there, going up like that, cutting off the line, and I can finish that off. Okay, a line, one point to another, have that point, so I have the line. So there's our perspective question. Perfect. Right, next one. Figure shows the outline of a pair of 3D cinema glasses based on two regular pentagons, same size, same angles. Write down the measurements for A, B and C. Okay, so A anyway is straightforward enough. If the radius is 15, then the diameter is 30. So I'll put in 30 there. B, a little bit of working out in this. So I know, I just said there that the diameter is 30, so that's 30, that's 30. The distance from there to there is 74, which means what's left in the middle, 60, or 74 minus 60, that means that's 14. So if that's 14, and that's 15 to there, that means this is 29. Okay, and then C, well, the external angle on a pentagon, as you know, would be 72. If I didn't know it, I'd divide 360 by 5, which there's 5 sides in a pentagon. The external angle on a pentagon is 72. And if that's 72, and that's a straight line, that means that entire angle is 180. So 72 plus 108 will give me that 180. So it's 108 I'm missing. Okay, there's the back of that. So that's 1, 2 and 3. Right, go to 4. Right, question 4, lads. There's always 1 or 2 sketching questions inside this. So this is basically an isometric question. One of the isometric questions we did, but it's in sketching. So you've just obviously sketch your answers. So you can see here they've given you the base already. So if we just, I'll draw it in lightly. I can finish off the base of that. So this is this rectangular base you see there. So what we'll do next is we'll do this kind of slanted kind of plinth, and we'll forget about the bit on top a second. So this slanted plinth, you can see it started there like that. So they've drawn it in, it goes in 1, 2, 3, so they've done it here, 1, 2, 3, so that's fine. It goes all the way over to 1, 2, 3, 4, 5. So there's 1, 2, 3, 4, 5, right, grand. I'm doing lightly now in 2H. Then so this goes back at an angle. So I can see here from here it goes in 1 to get this top point here. So draw a line, I need 2 points. So I have this point here down the bottom, and this top line one here comes in 1 and then up 1, 2, 3, 4. So if I come in 1 and up 1, 2, 3, 4, there's the point on top. So if I join that back to there, there's my point. Then from there it goes across 1, 2, 3, 1, 2, 3. Then I join that back down to the bottom line there that I got a while ago. I'm doing it all in 2H because some of this could be blocked later on. So there it is there like that. So there's my plinth. Alright. After that then we have to put this little thing on top, or this kind of bucket joke on top. So I can see from the back, so from the back this sticks out 1, 2 from the end of this. So it comes out 1, 2 from the end of that. So 1, 2, so there's that there. Then it goes out, so it comes out this way. So this bottom rectangle here, we'll say, goes out 1, 2, 3, 4. 1, 2, 3, 4. Goes across that. So this is kind of the bottom rectangle of it. Same on the other side, it goes out to this side as well. So 1, 2. Right, so you can kind of make out there's the bottom rectangle of that. Now after that we have to draw the top rectangle up here, and then we'll join the edges. So the top rectangle, same story. So at the front here it doesn't just go straight up. It's not a cuboid. It goes straight up and then it slants out this way. So it goes up 1, 2, 3 and then out 1. So if I go up 1, 2, 3 and out 1, well, there's the end of that line there, like that. I can do the same this side, or I can bring across the number of dots that I need. So I'll just do it the same way. So I go up 1, 2, 3, out 1. So there's the slant there on that side. And then I can either count up these dots or do the same on the other side. So I'll just do the same on the other side. 1, 2, 3, out 1. There it is there. And I could draw on that one, but I actually won't need it. I can see here that I won't even see it. So if we join that across, I'll go across further than what I need here. 30 degrees, so these dots are giving me the 30 degrees. So I can see there's my rectangle up top. So there I am sorted there. So to finish off, so I'll just fill in what I need then. So I have everything then. I'll just fill in H what I need. So I'll see this, I'll see this, see the base of that fella. Now you've been doing this with H pencil, remember I'm only doing marker, so, or felted pen, so you can see it better. So H, right, so I'll see all of that. Now if you want to leave that as a flat bit on top, that's fine. I think that should be okay. Or you can do it like it's open, like you're dropping stuff into the weighing scales. And that's what it looked like there, like that. That would be what it would look like. You'd say the top is open, but you can leave the top for flat if you want. Then so it comes down here. See that? This one goes up until it stops. I can't see anymore after that. And I'll be able to see the back. I'll be able to see that as far as it goes there. Okay, so you get, I think, pencil here, right? So if we read the question, the elevation and end view of the weighing scales are shown on the square grid. Make a freehand pictorial sketch of the weighing scales, colour and shade the sketch. So for that, you can see that that's nearly spot on there. For that, I'm only getting 9 out of 12 marks. You need to shade it always to get the full marks. So what I do is I'll decide where the light is. So I'm going to say the light is up here. You don't have to draw a light if you want to. So I'm going to say the light is shining in on top of that. We'll say in hitting this line from the inside here, like that. So it's hitting that line from the inside. Let's say it's tilted over here a little bit. This bit here is getting a little bit of shade. So the light is going to be hitting directly on that. This is going to be getting a little bit of shade here. Got that in there. But this side is getting nothing at all. I'm going to go to town on the shading in this fella. Same on this side. This bit here will get a little bit of shade here like that. But this side here, if the sun is shining in on that, this thing is seeing nothing. Nothing at all. Right, sun is shining down there. This is getting a good bit now because the sun is hitting this directly, whereas on this side it's not hitting anything at all. So it's going to be dark there. Then this is going to be slightly lighter. So the sun is shining down on that, it's hitting all of that. That's adding a little bit of shade, but this side. Same up here. The sun is shining down there and this way. So this is getting a little bit. This is getting a load of it because it's hitting that directly. Maybe this not so much because it's going to be covered on the other side. Right there, like that. So look, that's we've a shaded in there. That'll get you full marks. All right. Maybe if you close in the white gaps there in between, but you're not doing too bad there with that. Right. So this is like one of these internet puzzles. That's how many squares, rectangles, and triangles. Well, there's one for squares. 1, 2, 3, and 4. 4 squares. Rectangles, we have 1, 2, 3, 4, 5, 6, 7, and 8. There's 8 of them there. Triangles. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. These ones. I can't remember which. There's 14 of them anyway, lads. You can put, if you want, you can put numbers on them. Maybe that's what I'll do here. So I'll do 1, 2, 3, 4, 5, 6, 7, 8. So they're all little ones. 9, 10, and the big one here. 11, small one here. 12, the big fella here. 13, and the smaller fella here is 14. It's 14 triangles. Okay, right. Next question is, it's a rotations question, lads. So it's the same as transformation geometry. So in transformation geometry, we remember everything. How does it move? How does it stop? So everything moves by rotating around a point, and everything stops because it all goes the same angle. All right. So what we have here, the figure below shows the elevation of a stapler. A 3D graphic is also shown. Rotate A, B, C, D and E about point O until point E reaches LL1. So they haven't actually given us an angle, but what they've told us is when we open up the stapler, when E hits LL1, well, that's the angle that everything has to go. Alright, so point of rotation, they all rotate around point O. So we get our compass here. I'm going to actually tape this on a bit, because taping it to keep it steady. Alright, so it tells us E, so there's point of my compass on the point of rotation, and then I rotate E till it hits LL1, bang, so there's that. And while I'm at it, I'll rotate everything else. So there's D rotating, there's C rotating, there's this one here now is a little bit more awkward, small little there's B rotating, take my time with that, and there is A rotating. Okay, so I've rotated all lines. Right, so to get E1, I have to rotate E up, so there's the E rotating up, until it hit the line LL1. Well, if that's E rotating up and it hit that, well, that's E1. So this is the HUD hinges, this is the rest hinges on all of this. Right, so now that I've got E1, well, I have the new position of E1. And I have D moving, C moving, B moving, A moving, and all I need to do is stop them. Now, you could take that angle there and then measure up that angle there. It'd be 20 something if you measure that angle there like that. And then draw your line from the point of rotation to that point, make your new angle and draw it up there. But another handy way of doing it is, well, if the distance from E to D is that distance, well, the distance from E to D1 is going to be the same. So if I take the distance from E to D like that, well, if that's D moving along when I opened up the stapler, that's where it stopped, because the shape of the thing hasn't changed. So if E1 is there, well, D1 is there. So that's D1 there at that point. D to C is that distance. So D1 to C1, same distance. So I'll rotate it through there. So there's C1. C1. Okay, same C to B. There's C, rotate it through, so there's B1 there. And then we've got A to B, take that distance on your compass. And if that's the distance from A to B, well, that's the distance from A1 to B1. I'll rotate it through there like that. Still a point there. So I've all my points. Now I just draw it in. So if A joins to B, A1 joins to B1. B1 joins to C1. C1 joins to D1. D1 joins to E1. And E goes all the way back to A. So E1 joins to A1. And there we have it, lads. There's what the stapler looks like when it's opened up. So there's what the stapler looks like when it's opened up. Doesn't ask to do any shading or anything, so we've that question completed. Okay, I'll take this off. I'm just going to put this in charge. Okay, so question 7. So we've actually done this, but we did it in a separate way. I remember telling you that you could do this question in a different way. So if I wanted to get the true shape of surface S, remember when we were doing orthographic projection, you do your elevation and plan. But the problem is, like, I'm standing here looking at that elevation. That's the view I'm getting. And as you know, if S is going in this direction, well, I can't see the true shape of S. Now, what we would have done in orthographic projection is we'd have rotated that surface around so that we could see the true shape of it. But this is an alternative way of doing it, and I might show it to you next year in orthographic projection. So the figure shows the outline, elevation and plan of a security camera. A 3D graphic is also shown. Project an auxiliary elevation of the camera on the line x1, y1 to show the true shape of surface S. Now, there is an alternative to doing this. So, remember I was saying to you before, so your elevation is basically, your elevation and plan is the two planes. So you've got your horizontal plane and you've got your vertical plane. And I draw my plan on here and I draw my elevation on here. So if your object is sitting in here, well, it's projecting the plan down there and it's projecting the elevation onto there. Now, the crease here is your XY line. That doesn't have to be. You can change that XY line if you want. You can change that so that instead of me projecting against there, I'm going to turn around so I can project against there. So I get the same object, it's just a different view of it. Now, if you take it here, so there's my plan, and I'm looking this direction. Now, the direction I want to look in order to see S is I'd have to walk over here, to this side of it, and I'd have to look straight in at that there, directly in at 90 degrees to that. That's how I'd have to do it. Alright? Now, if I walk from there over to there and look in that direction and set up my new elevation up here and flatten it back, I'm seeing the same object, I'm just seeing a different view of it. So, all the heights off the ground, I could run around that all day, the heights of them will never change. So the heights of everything, no matter what way I look at that object, that camera, no matter what way I look at it, the heights are all going to be the same off the ground. So, what I do is, same as what we do for elevation and plan, I go perpendicular to the XY line, so I'm going to go perpendicular to the X1, Y1. So I take all my points in plan, so now I'm drawing a new elevation, forget about the old one, there's my plan, and I'm projecting up a new elevation. And what I do is, I'll just start with that. Okay, so I'll project up my new elevation. Now, if you imagine standing looking at that, we'll forget about this little pole in the middle. If you imagine standing looking at that, S is all I'll be able to see. The surface, these two things, this surface here blocks everything else inside. I know when I'm looking at this side, I'd be able to catch the inside there, I'll be able to see a little bit of it if I'm standing looking at that. But when I walk around here, all I'll see is this quadrilateral on the side. So I have the points on the quadrilateral. You can see here I've projected them up. Now all I need is the heights. So there's only two heights. There's the XY line and the two heights above. Remember I said none of the heights change. So I just draw a vertical line there just to give myself same heights. So I'm going to label these actually. I'll label that H1 and I'll label this side H2. So if you imagine that quadrilateral, I have everything inside them two heights. So I'll take H1, there like that, mark it here, and I'll do the same for H2. There's the second height. I'll mark that out on this outside line here as well. And what I'll do is, just to save myself time, instead of scribing it a load of times, I'll just take a 2H line and I'll draw it right across. So parallel, if I was doing it here, I draw the H1 line parallel to the XY, parallel to the XY and H2. So I'm going to do the exact same with the X1, Y1. So there's my line there. And there's my line there. So there's my two height lines. So I got H1, H2. Right, so you'll do the labelling a bit better than I will. Okay, so if I want to draw this surface S now, so there's the top corner of it there. I have it here. Here's the top corner. So that top corner is at H2. I can see there it's at H2. So there's that point there. Then it goes down to this point here on the inside. So this line here, which is at H1. And then the back of it goes a line going straight up from H1. This back corner here is a line going straight up from H1 to H2 like that. So the quadrilateral I'm looking for, or the view that I will see of this speed camera, is there. So there's my quadrilateral there like that. Now, what I'm missing is the pole, so it can rotate around, or it's standing on top of this little pole or cylinder. So what I'll do is I'll have to draw that cylinder. Now, to draw it, I'll have to give myself a line here that gives me the far side of the cylinder and the far side of it on this side. So I'm standing looking in here, what's the last generator I see, or the last vertical line on the cylinder on this side and this side. So to do that, I'll just go parallel to this edge, slide the set square, and I'll draw a line straight through the middle, and then that'll give me these two outside points here, this fella here and this fella here. So they're the kind of, if I'm standing looking at that, they're the two outside bits of the cylinder that I'd see. So dim two outside lines. Just take one of the lines I've drawn ready, slide it over, bring it up there like that, and up there like that. So there are my two outside. There we go. So there's my the little cylinder it's standing on. Now you can see in here, look, this is kind of just a hood around the top, but maybe to stop the rain or something. So the hood is still there, the camera is still sitting flat here like that. So that means that there are two hidden, or there's a hidden line going up along here, where on the kind of square rectangle that the camera lens is sitting on. So I'll draw just a dotted line in there like that. Alright, so that's going to be hidden detail. So there we are, lads. That's that question. Haven't done that before. If you want, you can just copy it on. We'll be doing a good few of these after, but you can see maybe the second or third go you'll be able to do it on your own, but try and do that as best you can. Right, so question 8, this is the second sketching question. This one is without the dots that we had last time. So remember, go back to isometric and what we did in isometric. So we have in isometric, if I'm starting off, remember the crow's foot, so I'll have 30 degrees going that way, I'll have 30 degrees going that way. Now if you want, you can use your protractor to start off. You're supposed to sketch it, but you need to get used to drawing them angles. You're going to be drawing plenty of these 30 degree angles, 30 degree angles. You can see there I can do it straight away, but I've done it loads of times. So you have a vertical line, 30 degrees, 30 degrees. And if you get used to drawing them, you'll go far, right? So what I'll do is, remember in isometric, I'll draw the box that this goes into, right? So you can see there, geez, if it isn't a square, it isn't far off it, so I'll go this distance out here, maybe that distance, so I guess about there, right? So if I go that distance there, I need to go the same distance up here, so I'm going to say there, something like that. Remember now it's a sketch. So I'll draw my 30 degree line, and my vertical line there, so that gives me the square on the side. The thickness of that box going back is that distance. I'm going to mark it off about there. I'll draw my vertical line up there like that. Now you can see here I'm drawing 2 H lines. Yours will barely be seen. I have to show them a little bit harder so you can see them on this video. So then it goes back 30 degrees there, and then from the back here it goes back 30 degrees there. So I have the kind of the cuboid or the box that it goes into done. After that, there's a curve up here, so it's starting about, that'll be a third, that'll be 2/3, so maybe 2/3 up the way a curve starts to 2/3 there. So there's kind of a curve going in there like that on the side, something like that. Alright, then there's a rectangle on top, so maybe that actually looks a bit thick. No, that I might. Rubber on top of these. So I'm going to rub that out a small bit. I'm going to make that a little bit thinner. Yeah, I think that'd be better. Alright, so there's a rectangle up top, so it sits in from the edge, comes in that much, so I might draw a line, something like that, across there, then to there, something like that. That line there is about, didn't far off halfway on the kind of rectangle, it's just inside halfway. And then these 2 lines come in there and in there. And the height of that is there and there. 30 degrees going back that way. 30 degrees, so I'm doing this, you're doing this lightly now. So there's my kind of rectangle sitting on top. The switch or the switch or of the measuring tape. Right, so I'm gonna draw in there what I have. Okay, and I'll draw this side of this. So I'm going to draw that down there. The curve going down and along. Right, so that in there. Right, so that much drawn. I'll put the curve on the inside of the same curve, so it's going to start across there and end across there, so it'll be the same curve within reason. So remember, it's a sketch now, but I'll try and do it as best I can. So there's the curve there, then it comes down there like that. So that's kind of the box of the measuring tape. I'll finish it off there now after. That's kind of the box of the measuring tape. After that, I've got a bit of tape that's sticking out, so you can see it's not flush with the edges, it's coming in from the side of small, but it's sitting that much off the ground. So I'll go about that and say that's where it is. It's going to start just in from the edge, and just in from the edge, and that 30 degrees, I'm going to have to keep that 30 degrees, so it's going to be parallel to that. So there it is coming out there, something like that. Then I'll cut it off, same distance there, about that, and it goes from there down, straight down. The kind of clip on the front of the measuring tape is there, so I think that'll do it. So if I finish that off, so I'll draw in this. Okay, there's the point of it. That'll hide some of that. Then we'll come up here, curve around, comes around the back there like that. Now you can see there the way I'm drawing these lines, lads. a lot of you have a tendency to kind of do these hairy lines going along like that, and I wouldn't be on it. I'd say just draw a line once. Like if it's wrong, draw it again. Try and get it done in one go. Hairy lines don't look great. No, some of you are good at it, but a lot of the time they aren't great. Okay, so I'm just going to get this bit that's offset into the middle, so it's the same shape, just offset into the middle, so it's that distance from all the sides. So I want that distance out, that distance there, and then I'll offset the curve the same distance. It's probably something like, I'll do this one here on the top, and that curve is something like that. Right, there we go. Right, so there's the kind of inserting inside the box. Now, same story, lads. Whenever you're sketching, don't get caught with this because it's money for jam. You want to get, just get two colours here, or you can do shading if you want. So remember, it says colour or shade on the completed sketch. So colouring doesn't mean like the way you used to in primary school. So remember, if the sun is shining down this direction, well, this bit of it here is going to be a little bit darker. So I'm going to do all this bit green, all in here green, and I'll do the switch and this, what do I do it, orange, that in pair, right? I'll do it blue, right, green and blue, right? So, sun is shining this way, this means all this side here is going to be dark, right? So I'm leaning heavy on this green crayon or twistable here. You can use a colouring pencil if you want. So I'm leaning heavy on it. Now, when it starts getting up here, it's going to have to get lighter because the sun is shining more up here. So there's going to be a shine on the top there like that. And then, so I'm going to have to go from this really dark side to that light side in a gradient. That means gradually. So it shouldn't be dark, light, it should be gradually. So I'll go the same colour as the bit on top first. Then I'll come further down and go a little bit darker. Then I come further down, go a little bit darker again, and you can see there they've it kind of gradually goes to 10 and it looks like a curve. Alright. So that's green. The light is shining there. This bit will probably get it'll be a little bit darker, but it'll be darker than this but lighter than this. So, and it's all a flat surface, so there's no kind of graduating here. So I'll colour that in there like that. That should be fine. Okay. This switch here on top, so I'll do the rest of it. Maybe I'll do this, the front of the catch here, and that green as well. So remember, sun is shining in this way, so that bit's going to be dark there. It's going to be the same as this. I'll do the rest in blue now, so that's going to be one colour. So I'll draw that in there. That's fine. Okay. So if the sun is shining there, well, that means this side of it here is going to be dark. This bit here is going to be a little bit lighter, and the bit on the top is going to be lightest of all of them. So, and we'll do a bit here as well. So it'll probably be black, but just do a little blue on that. Right, so there's our that's our measuring tape there, and we've coloured and shaded. If you wanted to, it's a nice thing to do when you're sketching. Just one thicker line around the whole outside of it. So if you imagine you're shining a flashlight from the back, that you can't see, well, what edges would it light up? Right, just gives it a little, pops it out from the page, it's marked. Right, so that's full marks for that question. Okay, question 9. So we have write down any 3 CAD commands used to edit the drawing of the picture frame as shown in the sequence below. Now, I don't know if you've done CAD or not, you haven't done it with me, but there's about maybe 8 or 9 of these, and they always come up. One question always comes up in it. So look, once we do a few of them, you'll have them all, but I'll go through what we have anyway. So this is the one that you start off with. So they're asking you from there, 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 and there. So there's 4 things have happened. Something's happened between there and there, there and there, there and there, and there and there. So they want 3 of them. All right. Now you can see here this bit doesn't reach out to the end. The command that extends a line to the end is called extend. Right. So you can put in extend if you see something like that. If there's a line that has been completed, it's called extend. You might even guess this one. So if it goes from there over to there, in transformation geometry it's called axial symmetry. I would have shown you example where the child was looking into the window or whatever, the mirror. So it's a mirror. When you use that line as axial symmetry and bring it over here, that command is called a mirror. So you're mirroring one side onto the other side. So mirror is another one. If you take, I actually mentioned it up here when I was doing that, if you remember the word I used to draw that inside one. When you draw the same shape, so if the same shape on the outside comes in the same distance on all sides, that's called an offset. Alright, it's called offset. Right, so I've taken that, I've come in the same distance from all the sides, and I've made a shape on the inside. It's called an offset. Offset. And the last one there, when you turn something from 2D and you project it straight up, like we'll say it's going straight out, like we'll say if that was the frame inside, and one of them Play-Doh yolks where you squeeze it down and it shoots out that shape in a direction to make it 3D. So if that was like the outside of the Play-Doh yolk and I squeezed it through to make they all come out the same distance, that command is called extrude. Right? It's called extrude. So there's only 2 or 3 things you need to know to make something from 2D to 3D, but the most common one is extrude. All right, when you project, they all come out the same distance from each side. Right, page. Okay. So that's 8, 7, 8, and 9. That's 10. Stick this down. Okay. Figure 1 shows the design for a glamping pod. Shown in figure 2 is the incomplete elevation of the glamping pod. Complete the elevation in figure 2 by constructing a parabola in the rectangle ABCD with its vertex at O. Alright. So as we know, lads, if you're doing a parabola, we'll deal with half of it first. So we'll deal with half the parabola first. So we've got a rectangle here that it goes into. Remember, we divide each side of the rectangle into equal parts. So I'll be drawing a line straight out here. So that's one side of it, and I'll divide that into equal parts. I'm going to go 4. So I'll go 4 half centimeters. So 5 mil, 5 mil, 5 mil, 5 mil. Join the last fella. The last one to the end of the line. Okay, and if I divide that side into 4 equal parts, well, I'm going to do the same on this side. So I'll just draw a line from one end, any length, any angle, and I'll measure off 4 equal distances. This time I'll do centimeters on this because it's slightly longer. So 1, 2, 3, 4. Alright, join the last one. That one's slightly off there. Okay. Right. Now remember the labelling, lads. So I start at the vertex of my parabola. So the vertex, or the part where the curve is at on its top, or the top of the curve, is called O in this situation. So I go from O, 1, 2, 3, skip the corner, 1, 2, 3, like that. And remember, the line that the line of symmetry on the parabola, so this one here down the middle is the one I'm concerned with. So there, that's the direction I need to draw my lines. So the line that splits the parabola down the middle is this line going down O. So I'll use that line and I'll draw vertical lines going on like that. 1, 2, 3. There we go. Alright. And then I join my vertex to O. Or sorry, join my vertex to 1. Join my vertex to 2. Join my vertex to 3. Okay, and where V to 1, or O to 1 in this case, O to 1 crosses 1 is a point, where O to 2 crosses 2 is a point, where O to 3 crosses line 3 is a point. So there's my points, and I'll draw it in a second, and then, as you know, we'll just use axial symmetry to draw the other side. So I'll use this line as on the bottom. If you were stuck on with a T-square, good for you, but I can use this line as the bottom, or on the bottom, to draw my line straight through the line of symmetry there, and use my compass to draw the other side. So there's that distance, that side. Same down here, line of symmetry to the point. There it is out that side. Same down here. Okay, so there's my lines at the other side, or sorry, my points, there and there. So remember, we can use the kind of light, hairy line going up. So, going up along like that. Very light, because this isn't going to be a real line. Goes up to the top there, all the way down the other side. And then if you can, just with your H pencil, one line following the path that you've made. Give yourself a nice neat. There we go. So there's our parabola. Brilliant. Okay. So figure 1. So figure 1 shows the development of an object. 3 images of the objects before developments are shown on the right. From the images on the right, match the letter for the development shown in figure 1. Right. So we have to try and figure out, what does this all folding together make? Well, I can see that I can rule out A anyway, because there is a back to it. If you imagine two of these sides coming up, there's a back here and that. B, we won't rule that for out a while. C, well, I can see from this that there is no top. If there was a top, there'd be a bit added on there, so it's not going to be C, is it? So it ends up that it's B. So that all folds together to be B. Alright? Okay. So what have we got here? The incomplete outline of a shelf support is shown. A 3D graphic of the support is also shown. Complete the outline of the support by constructing the internal tangent of the two given circles. So an internal tangent, lads, means the tangent doesn't go like that, it goes like that. It goes on the inside. Okay? So it's one of two things all the time. So you cannot get a tangent between two circles. So if someone asks you for a tangent of two circles, you have to immediately think, I actually can't do that. I'm going to have to do something first before I get the tangent between two circles. Now, as we know, we're able to get the tangent between a point and a circle. So what you need to do is you need to reduce one of them circles down to a point. But you can't just reduce it down to a point. You have to do something with the other circle to counteract that. So if you're doing an internal tangent, you'll always reduce the smaller circle. So this is going to go down to a point. But if I take that radius off that for an internal tangent, I have to add it on to this fella. Okay? If it was an external one, if it was a tangent going from on the outsides, I'd have to take it away. So for this particular, for an internal tangent, I have to add this radius onto this fella. So I'm going to draw a line out like that. I'm going to take the radius of this guy, and I'm going to add it on to the end of that. Now when I add it on to the end of that, the other circle disappears. It becomes a point. So I've taken it off the original circle and I've added it on to the end, and I have the new circle in there. So now I have a new circle and a point, okay? And I just work away as normal. So I have a new circle and a point. Well, if I want to get the tangent between two of them, I join the point to the centre of the circle. And as you know, what do I do with that line? Well, I bisect it. So I take my compass, more than halfway, swing an arc, do the same from the other side, same distance, there and there. There's actually on the one on the circle. I get that point and that point. And I draw the bisector going through that line. So there's halfway on it. And now I draw an arc using that. So I'll draw the full semicircle. Going like that. So that point there is the point of contact between that point and this big circle. If I drew that through, there's my tangent. I'll show you there on my ruler. There's my tangent there between the two of them, right? Now, the reason why that's important is because the tangent I'm looking for is going to be parallel to that. That's why I have to do that first. So the point and the big circle, I added that onto it, and I got the tangent between that point and the big circle, and that line is parallel to the one I'm looking for. So, to draw in the one I'm looking for, if I just join this fella back to the centre of the circle, like that, okay, that will give me the point of contact of, so I'll actually draw that in. I'll draw in the first tangent. So there's the first tangent. Okay, so using that tangent line, I go 90 degrees to it. So 90 degrees is going to be going from that to the centre, but you can draw it in. I'll slide it over this way. So I go 90 degrees to it. That should be to the centre, which it is. I'll do the same this side, 90 degrees to that line from the centre of the circle and get on the top of the circle there on this side of it here. So now I have this point here, which is the point of contact on this side of the circle, and I have this point here, which is the point of contact on this part of the circle. So I'll just show you it's 90 degrees, and that's 90 degrees, and it's going to be parallel to this line. So now I have my 2 points of contact, and now I'm able to draw in that little design. So there's my H line going from that point into that point there. There we go. So you can see there is my tangent in there, and actually what I'll do is this, you can see there's a thicker line going around. I need to join that up to the end because there's a gap here, so I'm just gonna show it like it is in the design. So there it is there, finishing off there, up the top, finish off the line there with that. So if it's an internal tangent, you add the radius of the smaller one to the bigger one, alright, and reduce that down to a point. Grand. Okay, let's take this for that. Right. Take this one on. Right. the figure shows the outline of a house. Draw a new outline to the given house with the length AB increased to AB1. So I need to draw a new outline to the given house with the length AB increased to AB1. Now lads, we would have done this in rotations. Remember I was on about how where there was a question with a fish on it. Remember there was a hexagon and a triangle and we had to increase it. Now what they're saying here is you basically have to enlarge this house, make it bigger, so that none of the kind of ratios, that height to that height, if that's 1 centimetre, that's 4 centimetres, and the new one is 8 centimetres, well that's going to be 2. 2 is to 8, 1 is to 4. All the ratios stay the same, so that's enlarging. And you remember what I talked about, I went on about a flashlight, and that you're using the flashlight here, like me with my handler, so one point is going to stay the same, so to enlarge it, I need to figure out where the light is coming from. So my light is coming from up here on the camera. So I'm going to have to figure out what point stays the same and enlarges everything else. So where is it going to go? Well, AB1, what's the one that stays the same? A. So if you imagine there's like a little flashlight there shining in the corner and it's projecting all the points through there. So I'm like trying to enlarge it up to this side. None of the angles will change on any of the lines. So if B goes straight up, the line at B1 goes straight up. So I'll start with that anyway. So I'll take the line at B, there it is there, and I'll draw that fella straight up here at B1 like that. Right, that'll give me a good starting point. So after that, I'll shine the flashlight from A and I'll take every point I can see. So from A, I'll draw through all the points there. The one here up the top corner, there, this one here, here like that. This one is going to go straight up there like that, right? So in other words, I've shone my flashlight through all the points. Okay. Now that line goes straight up from B up to that top corner of the house there. Well, if that's the top corner of the house there, when I enlarge it through there, the only measurement I know is the same, or the only point I know is the same, or the line is this B1 line. So that's B, that's B1. Well, that's after enlarging to this point there. So now that's the new height of my house. So everything else will go off this. Remember, none of the angles change. So if that's 90 degrees at B, it's 90 degrees at B1. At the top here, well, this is 90 degrees up here, so I can draw this line going straight across. Here's my sliding set squares. This line goes straight across until it hits this corner of the chimney. So there's A shining through it. So that's where that stops there like that. Alright. After that, it goes straight down. So it goes straight down till it hits this point here. It goes down there like that. So up here it's going to go straight down till it hits this line. So there it is. There like that. Okay. After that, remember, none of the angles change. So it goes at that angle here. Well, it's going to go at the same angle. So I'll slide that up. There's A shining through the apex of that roof. There it is, going the same angle till it hits the apex of the roof. And there's the angle going back the other way until it hits the line going up here. So there is there's the new house. A similar house but enlarged. So all the proportions are the same. It's just larger. So I've shone it through A. A was the one that stayed where it was and everything else got bigger. Right. After that, we've a third sketching question, is it? So the graphic shows a set of steps. Draw a well-proportioned freehand sketch of the plan of the steps. So we have to draw the plan. Right. So Gonna have to do it freehand, so we'll have to imagine what we'd see. So look, just for us, I'll shade in. So if I'm looking from above, I'll see this fella. See the top of this step here like that. I'll see the top of this step. I'll see the top of this step. So I can kind of imagine what the thing will look like. They're all probably the same there like that. So I'm going to have 3 rectangles, and then the last rectangle is going to be curved. So I'm 3 rectangles, and then if I just guess there, that the end of that is probably the length of another step again, is it? So if I was to draw that out there, so you probably 4. If you took 4 rectangles of the same size, and then just didn't include the last one, that'd be a good way to do it. So I'm going to draw this down here like that, and I'm going to divide it into 4. So there's the top and the bottom. There's about halfway, and then find halfway there, halfway there. So there's 4, right? And I'll draw them out. So the length of that, it's the length going down this way. This bit is shorter, so it's not a square, it's going to be a rectangle. So I'm going to say about there, maybe something like that. Something there like that. Yeah, I'd be happy enough for that for that, right? So remember I said if you were looking down top of it, if there was, you know, a 4th step there going out like that. So we said the last one is not going to be there. So there's my 3 steps, 1, 2, 3, and the last fella is curved. So it's not starting at halfway, it's starting about maybe 1, 2, maybe just over 2/3 of the way the curve starts. So maybe about there, something like that. Oh, wrong one, this one. It starts there, something like that. I'd be happy enough for that. Okay, so I have I'm going to draw that in fully because I'm going to be able to see it. So it goes all up to the top. Draw a full line again. Alright, so it goes across there like that. Down there. Across there. Drawing my steps. There's 1. There's 2. Right, grand. And then this last fella, how far across this? So the distance there is about the same as this. That distance there is about the same as that distance there. So I'm going to take away that distance and come in the same. About that, I'd say. Draw a line straight down there like that. Right, remember we said this fella here is going to start on like a 4th step. Oh yeah, it starts from here and curves out like that. It's going to be this fella across. It's going to be curving around like that. Like that. There we go. Be happy enough for that. Not too bad. Might be a bit thick there actually. It'll be alright. It'll be fine. Okay. So that's that. I'll shade it. Will I? I won't. Doesn't ask me. So I ain't doing it. So I don't need to do it if it doesn't ask me. Alright. So we're on to the last question, lads. So the 15th question. This is normally a graph. So it's normally some sort of bar chart or a graph like this. It's a line graph, it's called. So you can kind of see what's going on here. The car sales in a garage are recorded over a period of 6 months. These are the following results. Okay, so January was 50. So January was 50 and February was 30. So that's equal to 50. That's equal to 30. So what's going on between there? We've got 1, 2, 3, 4. So there's 4 jumps in between them. So there's 4 jumps in between it, and the difference between the two of them is 20. Well, that means they're going in 5. So that's 45. That's 40. That's 35. That's 30. This is 25, 15. So I'll actually draw them. So I'll go 50, 45, 40, 35. 30, 25, 20, 15, 10, and 5. I'll do 0 at the bottom. Alright, so January is 50, February is 30, March is 55, we'll put a 55 up there, So March is 55, so it's going all the way up past 50 to 55. There like that. April is 15. There's 15. May is 25. There we go. And June is 45, so it goes back up there. Not bad. Right. So there's our line graph. So they want us to show what's going on. So it went from February at 30 to March at 55. You might have done this in some other subject, but that's what a line graph looks like. There it goes up there. Then it goes from 55, big drop in April. Down to 15. Then it goes from April, May is 25. Then there's June at 45. Right. And that's it, lads. Normally in this question, actually, people get caught on it as well, same as the sketching question. They'll ask you to colour and shade it. Now, of all questions, that one is money for jam, but they don't ask in a line graph, they don't ask you to do it, but if it's a bar chart, what if you would just colour in the different rectangles. That's the 15 questions, lads. Can you do them, please? Thanks very much. I'll stick it up in the group there.